Swayam Prabha. Digital India. Educated India.
So as we move, so now we look at this in a very summarized form. So you can see we put few of these: skill, experience of work crew, construction method. So because masonry we did not list construction method here because we assumed it as a single method. Local practices, site characteristics. Okay, all of these, what happens is we come up with a factor called factored productivity. So I might say productivity of go back, I might say productivity is 20 square meters a day average, but I have to actually get into the site, look at all of this and then factor it appropriately to know what can I expect out of that site at that period of time. Now my factored productivity, and when I take number of crew, I actually get the production. Okay, I get the production. And this production, and when given the quantity of work and production, then I can estimate activity duration. Okay, so productivity, the way we are defining productivity is production per day per crew. So I want to again take this opportunity. A lot of times, where we have projects where they say, oh, they have to improve productivity, and so what do you think the control action is? They have to increase quantity of work to catch up with the schedule. So they tend to increase the manpower on the project. Increasing manpower on the project increases what? Cost.
Increases production.
Increases production. It doesn't necessarily increase productivity. Okay, so there is a difference between production and productivity, and ultimately duration depends on production and productivity. But depending on if time is really the most important issue there, sometimes rather than look and try to slowly improve productivity, the project manager might only have an option of improving production, and that's what sometimes happens, quite often. Okay, so now we move to when we have to calculate duration, what are the influences that come into play. So we have an activity duration here. We talked about activity productivity. Okay, we talked about construction method, site characteristics. All of these are influencing the productivity to get a factored productivity. We have quantum of work, and we know that we can change, or might decide on the number of crew to be able to change production and thereby change the duration. Okay. So for example, I'll take an example later, but just discuss this here. What of this is constant, what of this is variable? What are the factors here which are given to you which you can't change? What are the factors which you can change?
Duration
is fixed. Yes.
Sometimes we might fix the duration and depend on fixed.
Exactly. So you might fix the duration, in which case what do you have to vary?
Productivity, number of crew.
Yeah, you could vary productivity, but let me tell you, it's more difficult to change given a construction method, given a site characteristic, given a set of labor. You can change management practices to improve productivity. You can certainly do that, but like we just discussed, it's just easier to increase or decrease number of crew to change production, and when you change production, your duration decreases or increases, changes. Okay, so again I am reiterating, we could work on changing productivity, but that is really a little more difficult than changing production. Okay, and if you really want cost effectiveness on your project, you should be changing productivity and not production, and that's the next step. Okay, so we can go two ways, like we had been discussing. One is, if a duration is given to me, I can change, I should be able to find number of crew for me to achieve that duration. If duration is not a given, I have flexibility on duration, I can with my current number of crew I would put in, and I can find how long they will take to do the activity. Okay. So if we go with duration driven, so let us take an example here. Excavation of soft soil on a site has to be completed in 2 days. Okay, now we are fixing the duration. Total quantity of excavation is given. Okay, based on the previous what we discussed. Okay, we are going to try to factor crew size. Okay, let us take this flow chart here. So this shows you the example. So we have 2 days, which is the duration of the project. 1000 cubic meters is the quantity.
Total work.
Yeah, total quantity of work. Now, okay, so if I have to do 1000 in 2 days, each day I have to do 500 cubic meters, taking an 8-hour day. Okay, so that is so much per hour. Now, so this gives me, if I am bringing it down to an hourly basis. Now I come in from this side. If I have two options, I am looking at using an excavator or using manual labor. Okay, if I am using an excavator, this is the cubic meter per hour I can get, which means in order to achieve my required cubic meter per hour, I need 2 crew. Whereas if it is manual, this is the cubic meter per hour I can get, and this is the number of crew I will need to meet the requirement. Okay, it is pretty straightforward analysis. I can go the other way around, which we are saying is resource driven. That is, my methods, all of this is fixed, only my duration should change. Or by I mean I cannot mobilize more crew. This is what I have, and a lot of companies face this problem or face this issue. They actually say, this is what I can mobilize, how long will it take me to do the job or to do the activity. So if we go in this direction, okay, with the same example, so you have backhoe loader, and it's the same example in the reverse direction, where you have one unit 35 cubic meters per hour, and so with the backhoe loader you say 44 days is the total time to with one unit. With the manual crew you get 63 days of work. Now what is going to cost you more, time cost trade off, all of this can certainly be discussed, but it's a different issue. Okay, any questions so far? Now let's take an example which I want you all to solve. It's again it's not very complicated, but let's take it step by step and see how we bring in different factors. So here we have a masonry block, a masonry activity. There are 2 crews of 1 mason plus 1 helper. The total quantity of work to be done is 600 square meters. Productivity is 20 square meter per day per crew. Working time here is 10 hours per day. What do you think is the how long will you take to?
15 days.
Okay, so if I am going in from a productivity perspective, so I am saying duration is quantity by production. Production is productivity in number of crew. I find my production and I find my duration. Okay, now we any questions? I am sure there are no questions on this. It's very straightforward. Okay, we get into now we bring in these other factors we talked about. The challenge in this earlier place is certainly not the calculations, but productivity. Now how do I actually calculate production? How do I come up with this number, which really represents what's happening on my side? So when you go into this, when we extend this example, this becomes a little clearer. So here we have this. Now the same crew is going to work at a height of 8 to 15 meters on a scaffold. Before they were working on the ground, they could walk around. There was no problem. No safety harnesses. Nothing was required. Now they're going to work on a scaffold. Okay, as you can see here. And what do you think are the factors now that influence productivity here?
Working on a scaffold.
So why should will their productivity be more or less?
Less.
Why?
They have to be,
Working
they
area
have
is
to be
less.
more cautious.
Yeah, they have to be more cautious. Okay, they can't move around as freely as before. What?
And getting materials from
Yeah, getting the materials up is little more effort. That has to be done. If the mason has to walk to get some other tool or material, he has to climb down. Okay, that there's more time required to climb down and climb back up and all of this. So this is pretty common when you actually take on multi-story buildings. You find that as the building gets taller and taller, the productivity keeps decreasing. Even a simple thing like if the workman needs to come down for materials, the travel time itself just increases significantly. So of course there are many ways to counteract it. So in this particular case, all we are taking is now we have to come up. So we know that productivity of the ground floor crew is 20 square meter per day per crew. Now we come to the scaffold. How will we estimate the productivity? How will we have to factor the productivity? So we know it's not going to be 20, right? So here are some numbers I came up with. Okay, scaffolding and other equipment we are factoring by 0.9, movement of materials by 0.9, safety precautions for working at height 0.95. Like we discussed, these numbers are on what basis do we come up with these numbers is really a question. But if I have data, okay, if I have a means of actually collecting data of productivity of masons at this height, productivity of masons at scaffold at a certain height, then I could probably come up with more rational ways of coming up with this estimate. And that is really the critical. Now, given this data, how would I factor it?
Multiply all these factors.
Multiply directly,
Adjustment.
or each of them are independently reducing the
1 by 1 plus.
okay, they are all reducing the productivity. 20 is the base, each factor is reducing it independently by a certain amount. Okay, so you get 15 square meter per day, and now what was taking 15 days earlier is now taking 20 days because it is working on a height. Okay, so this is a factor this is one way of factoring. And if you actually go into corporate productivity norms, they will have factors like this, and those are such closely held secrets, because based on this is what when you originally make a bid for it, if you have these factors right, then you get your bidding and your target price correct. If you don't have these factors right, you can be anywhere over the cost part, and you might make a big loss, or you might overbid and not be competitive at all.
So these factors are merely based on historical and experimental data.
Yeah, unfortunately there isn't so much experimental data, but it is mostly based on so this is where, how can we make a factor like this based on experience? It's difficult.
Based on the importance, is it based on the importance of the factors which influence the productivity?
Yeah, but how do I come up with a number? That's still the critical thing. So let's just take a minute off. What would be the most structured scientific way to come up with this number?
So you work on a particular test project, you check out for a particular kind of task, given a certain number of crew members, how much is the productivity that is coming. I mean, depending on various factors such as the height, or the materials, ease of the site of construction.
Right.
All these factors you take into consideration and compare it with a standard test.
Right. So first is, there will be no test project as such. If you have to take a project which is going on and you do it. For example, on campus we have so many buildings being constructed. I have to now make sure that when I am recording the masonry crew, or when I know where they are working. At the end of each day I have to record what their productivity output is, how many man hours went in, and where. and then so then at the end of the project or somewhere when I have enough data, I have to say, okay, I have to sort out the data and say this much of height, this is the average productivity. As I get higher, this is the average productivity. So we take a 3 or 4 story building, we should be able to find out our productivity at different floors. We should be able to find out total productivity average for a 3-4 story building. But coming back is, one is we have to collect almost daily data, and we have to get the data characterized by location and by crew and by various other factors which are then required for the analysis. So a lot of times this data is not available, or these factors are not available today because people don't collect data at that level of detail. People will say output for the day is so much, fine, total number of people worked is so much, and they will get average productivity on that site for that day. You will not be able to get the finer characteristics of the work. Any other questions?
Sir, I think if we are going for finding any productivity factor, then we have to make other variables constant, which is highly impossible.
Yeah, no, that's what. So remember here, so if you take for example someone like, a lot of the companies have not only productivity factors based on something like a building and height, but they'll have region, they'll have size of subcontractor, they'll have experience of subcontractor, they'll have so many factors built into that. So you are right, there are a lot of factors, and it would be impractical to assume that only 1 or 2 factors are variable and everything else is constant. But the challenge here is there are, we listed about 8 or 10 factors, there are about 50 factors which go into productivity, and unless you keep collecting data on project after project with this fineness of attributes, you will not be able to do any analysis to get these factors. That's the point. So you take a large construction company which works all over the country. They'll have a number of projects. They will have to kind of sort out their data based on region, based on type of project in region, all of that. Or in contrast, you take a builder who works only in Chennai. Okay, he has to do the same thing. Okay, for him most of the labor, everything is is around Chennai based, material supplier Chennai based, everything, but still he has to be able to find different find finer details to the productivity influences to be able to actually estimate what he's doing. Okay, so this takes us back to our earlier discussion of project versus process. Because we are on a project mode, there are so many factors, and the example we are discussing, the builder in Chennai is more in a process mode, can be more in a process mode because his variables are less, whereas the person who's the company that's doing global construction is much more in a project. Okay, let's take this example further. We talked about working time. Okay, we've said 10-hour work day, but if I am going to take a 10-hour work day, it's what is the effective working time? Okay, so I think somebody had mentioned this point earlier that I am not going to be able to get a full day's work. It's the person is not going to be constantly working. So might be effectively it's only, like you can see there are breaks in the work time. At least in many of our sites we have a tea break, we have lunch break, we have another tea break, and we will get probably 8.5 hours of effective working time. And here we again have to be able to now modify this for the overall productivity and say, okay, what should have taken 15 days now takes 18 days, what takes 20 days takes 24 days. So you will find that there are a lot of, so even if we take the 8.5 hours of work, do you think people are actually working for 8.5 full hours?
No.
So again, how do we factor this? Okay, so it gets tricky, and we will find that we come in with a certain productivity estimate, but we are simply not able to hold the production to that productivity estimate, which means ultimately there's something going on in our estimating which is not accurate. and we have to take those factors and control those factors to be able to reach our durations which we are estimating. Any questions on this? Okay.